The C standard library provides several functions for formatted character output. Let's take a working copy of working.c and we'll paste it here into our working project. And we see here this printf function. And in this case, of course, we're just using it to put a string to the console. So if I compile and run that, it says hello world. This works in C. It also works in C++. In C++, you would use the header, instead of stdio.h, you would use C stdio. And the printf function is in the standard namespace. And even if you're using the normal IO stream header in C++ that supports cout, printf still seems to work there. And I've found that it works on every compiler that I've tried. If it's not working on your compiler, you'll want to use C stdio without the .h instead of the IO stream or in addition to the IO stream header. Printf is capable of a whole lot more than just printing out a string. Let's just declare some variables here. So there we've got some variables of some different types, and we'll go ahead and print them using printf. So I'll save that and we'll compile and run it. And there you have those values from those different variables. So the way that printf works is it takes a format string and it uses replacement tokens in the format string, and those replacement tokens get replaced by the various values from the arguments to printf, formatted according to the replacement tokens. And the printf version, the version that we've used here that's very, very common, it simply takes this formatted string and prints it on the console or sends it to the standard out stream. There are different versions of printf. There's, for example, fprintf that takes as its first argument a file handle or a file stream. So I could just say stdout, which is the file stream for the standard out, and I can compile and run this and it puts it in the same place. Or I could say stderr, and we'll see that that goes to the error stream, which comes out in red on this version of Eclipse. Or I could actually open a file, and then I could use that file stream pointer. I can close it here, and then it'll print it to a file. So we'll save that and compile and run it. And you'll see over here, if we select our working project, and I'll press F5 here to reload the directory, we'll see we have a file, and there's our file with that output text in it. There's another version of printf called sprintf, which will print this to a string. I'll go ahead and delete this file over here from the file system. And so I'll declare a string here. I'll give it enough space for this output string here. And then this will become OS. So sprintf will take this formatted string and it'll put it in OS. And then I'll just print OS with puts. We'll save that and run it. And there's our output from puts. This version of sprintf is actually very dangerous. What this does is it writes our formatted string to this character buffer, and it assumes that your buffer will be large enough. If my buffer were instead, say, 8 bytes long, and I tried to do this, we would have undefined behavior, which basically means that the program would crash and could become a security risk. And so there's another version of sprintf called snprintf, and this is the one that I recommend that you use all the time. You could use sprintf if you knew precisely how many characters you're going to be writing to your string, but it really doesn't save you anything, and snprintf is always safer. So here we can define a constant, and we can say our buffer is this long, and then we can put buff size here. Now we have a version of sprintf called snprintf that will limit its output to the size of the buffer. Our first argument is the address of the buffer. The second argument is the size of the buffer, and it will print at most that many characters minus 1, and then terminate it with a null character. So if I save this and run it, you'll see our result works fine. Now if I make our buffer too small, let's just say I make our buffer 8 characters long, and I'll save this and run it, and you'll see that this is perfectly safe. It's only printing out that many characters plus a null byte. snprintf is standardized in C99, and it's also standardized in C++11. So any modern compiler will have a version of snprintf. And in actuality, snprintf had been around for a lot longer than that, and most standard libraries had it even before those standards were written. The printf function and its cousins provide a great number of format specifiers for a vast array of different circumstances. Here I have a table that shows a few of the most common format specifiers. And of course, there are many, many more, and many options to all of these. And any good C reference will have a much more complete listing. In short, %D is for integer numbers, %F is for floating point numbers, %S is for C strings, %C is for characters, %P will print out a pointer, and %% will print the % character. And here are the function signatures for the functions that we've used in this lesson. There's printf, which takes a format string and a variable number of arguments. There's fprintf, which takes a file pointer and a format string and a variable number of arguments. sprintf, which takes a character buffer and a format string and a variable number of arguments. And I really recommend that instead of sprintf, you always use snprintf, which takes that character buffer, an integer that represents the size of the character buffer, and so it will print at most that size minus 1 characters to the buffer plus the null byte, and a format string and a variable number of arguments. So now let's delete our working files and run clean to get set up for the next lesson.